All right, everybody, welcome. This talk is called Who Tests the Testers? Giving this talk is Evan Kohilas. So Evan is a serial international speaker and engineering productivity advocate who values frictionless simplicity, taming tech debt, thinking in systems, and tightening feedback loops, all to improve developer experience and achieve nohumanerrors.com. When he's not working on his next talk or project idea, you may catch him as the assistant director for PyCon Australia, dodging magpies while bike riding, chasing frisbees, or defending Subway cookies. So now it's my pleasure to welcome to the stage, Evan.
Thank you so much. I'm so humbled to be back. All right, to start with, can I get some noise from anyone else who thinks this is an awesome screensaver? Yeah. It's quite fitting for a pipelines talk, isn't it? All right, so as you may have heard, I'm Evan, and I've dedicated a fair bit of my time on platform software engineering that reduces human errors through things like working on pipelines to run tests for our code base. However, I noticed that I myself made quite a few errors. And I don't say this because I think I'm this perfect person that should never make errors, but because it highlighted to me that these errors could have been prevented if there were tests. And so these events got me thinking, if platform teams can help engineers run tests for their code base, who helps the platform teams write the tests for running the tests? So today, we'll walk through this journey of mine in 3 parts. I'll briefly introduce what a pipeline is and cover how to make one, show how I found the ways that they can break, and finally, deep dive into the methods to stop them from breaking. All right, for this section, could I please ask everyone to raise their hands? We're going to do a little survey. Awesome. Okay, I didn't think that would work, so I'm going to keep your hands raised. I'm going to take a photo, because I think this is quite funny. Awesome. Keep your hands raised. Keep your hands raised. It is a survey. Keep your hands raised if you know what a pipeline is. Okay, no one lower their hands. That's pretty good. Don't put your hands in the hands just yet. Keep your hands raised if you've worked with a pipeline. Okay, a few hands went down. Keep them up if you've written a pipeline. Okay, a few more, not too many. Last one, keep it raised if you've written a pipeline that's failed on you. Okay, some people put their hands up, but no one put their hands down, so that's pretty remarkable. I think we're going to be in for a great talk. Okay, so that we're all on the same level, for those of you who haven't seen a pipeline before, they can look something like this. And to put it simply, you can think of them as a factory line, where each step performs different operations to get to the final product. But in our case, our operations can look something like setup, build, test, and with our final operation, deploying this built and tested product. So why are pipelines good? And why should you care about them? Well, they allow us in one case to create a streamlined process that automates what would otherwise be very manual. And in other cases, they act as a quality control. This is similar to a factory line that you would see in the real world. If any stage of the factory line fails, like building or quality assurance, that item, or in our case, some code, won't progress to the next stage and thus won't be allowed to merge or even be deployed. Now, while my journey, if you haven't noticed, takes place within GitLab pipelines, don't fret if you're a user of other CI tools. My goal here is for the ideas to be general enough to be applicable for everything. And for tools like GitHub Actions, additional resources will be given at the end. So the first part of this journey is making a GitLab pipeline. And to do so, we need to create a .gitlab-ci.yaml file that GitLab will use as configuration. And that's kind of a mouthful, so I'll just refer to it as a CI config file from here on. If you're new to YAML, think of it as a way to store dictionaries and lists, similar to JSON, but more human-friendly. We'll make a simple one now that one can use on their Python repo to ensure that the tests pass before merging. Here, we define that we want the jobs to run with a Docker image that contains the latest version of Python. And then we define a job with a name test job. Below, we define script as the command to run for that job, which for us will be a Python file called test.py. Of course, this is probably the simplest pipeline that we could create, and thus shouldn't be used as a reference. This is because it's utilizing a lot of what GitLab is offering by default. And we can get away with things like not having to install any packages that these tests might be using. So if you are looking for reference pipelines, I'll have some links as resources at the end. That being said, my goal here is to talk about how to test pipelines. And given how simple this example is, it probably doesn't best mimic the issues that a real pipeline that I've worked on might. So let's extend it to do so. To do this, we'll add some rules, which decide on what conditions the job runs. We'll then specify that we want the job to run whenever there's changes that have been made, such as changes to any Python files. And this is so that we can speed up our pipelines by not unnecessarily running a costly job on unrelated changes to other files within our repo, such as documentation. Another thing we might extend on is having to run different types of testing jobs. For example, a database test job, which we could set up in a similar way, except it might depend on some test databases that have been created. And so for that, we'll require a new setup job to be run, which needs to be run under the same set of changes. And additionally, we need some way of specifying that the database test job can only run once the database setup job is finished. To do that, we can use the needs keyword, which specifies that the database test job needs the database setup job to finish successfully before the tests can be started and completed correctly. With the idea being that we want as much running in parallel as possible, such that our previous tests don't have to wait for setting up databases if they don't depend on them. And so now what we've landed on is great. It's simple enough as an example to what I was working with, and it works when it's merged in. However, as new PRs are made and time goes on, one PR causes the pipeline to fail. Not because the tests themselves pass or fail, but because the pipeline itself has become incorrect. And GitLab will tell us that the database test job couldn't run because the database setup job didn't run. Now, if we go back to our previous pipeline definition, can anyone tell me why it didn't run? Yes? Yes, that's right, thank you. It was because there was a typo in the changes. So the database test job ran because there were changes to files ending in .py, but the database setup job didn't run because there weren't changes to files ending in .pu. And that's where we have this mismatch. And the reason I want to give this example is because it's a type of problem that I've personally experienced. And it left me feeling quite frustrated and disappointed. And if this isn't only because I had lost time, then why? Well, while it's great that we figured out why this happened and the fix would be a simple one-character change, in our line of work, it's more important to understand how this was allowed to happen in the first place so that it doesn't ever happen again, because these kind of mistakes are costly. And so for this, I'm going to hand it back to Over Yor. Can anyone shout out some examples for why this problem could have happened? Feel free to shout. Yes? Yeah, actually, that's a good point. I didn't consider this. The U and the Y are quite close together, so you could have had a typo, and maybe there wasn't any tests to catch that. Anyone else? It is quite hard to see you all, and I'll be honest, that is on me, because I kind of expected that with a room this big. So
Like if you were switching the part that was looking for specifically the test for the database, and
yes, yes.
realize it's depending on different things in the database section, which could be much farther up.
Cool. So for the recording, it's that if it's defined in multiple places, then you might have changed it in one but not the other, and then you have this problem of don't repeat yourself. There's repetition everywhere, and it's not caught. Is that correct? Cool, okay. In the interest of time, I will cover some other guesses that I think your awesome responses might have been. I've got here that maybe when you put it through the reviewers weren't sharp enough. Maybe your config is too complex, and maybe you were just tired or careless or whatever. But to me, all of those problems are all human errors. And as you might have heard earlier, I don't like human errors, especially ones that could have been avoided by a systematic change. These would allow us to blame a system instead of the people. And this is why I was so frustrated. So I would say at a higher level, this occurred because while this configuration looks like code, it isn't treated like code, because we're used to testing code with tests. But who tests testing infrastructure with tests? Can I get a raise of hands? Okay, one person. Great. Awesome, we should talk later. Okay. So now you might be thinking, Evan, I'm so sorry to hear that. It was such a touching story, but solutions speak louder than problems. How can I stop this from happening to me? And yes, I'm so thankful. It was so difficult to share all of these experiences, and I'm glad you asked, because throughout that time, I was able to compose of 5 techniques that helped me that I want to share with you now. The first is validating our CI configuration using linting tools. The second is running an end-to-end CI pipeline before committing changes. We'll then, We'll then look at how we can run those pipeline jobs locally, how we can run static analysis testing on CI configuration, and finally, we'll look at dynamically generating pipelines using tools. Now, I'm not going to be here and claim that any single technique is best. My goal here is to cover the pros and cons to help you decide which one or which combination works best in your situation. And so the first method that we'll dive into is linting the CI config file. Linting is great. I love linting because it's a fast method of finding and sometimes automatically fixing problems that can be solved before going any further into that whole pipeline process. And GitLab, thankfully, offers quite a bit here. They have a VS Code extension, which will tell you within your editor whether your YAML is set up correctly. They have a pipeline syntax checker, which will do the same thing as the extension, but through a web UI and API endpoint. They also have a visualizer, which gives you a quick way of helping you see the dependencies between jobs. They have a validator, which simulates a Git push event on the default branch with rules and needs evaluated. And finally, they have a tool to expand your YAML into its full configuration, which helps you see what the pipeline looks like with all the special syntax expanded. However, these methods have their downsides too. The VS Code extension, for example, as you might have guessed, is only officially made for VS Code. And even if you instead use the pipeline syntax checker, whether it be the web UI or the endpoint, they only tell you if there's something wrong with your schema, not with how it runs. The visualizer, while handy, doesn't help you understand the issues we had around dependencies with needs and rules, and thus won't uncover those issues up front. The validator, while it simulates and evaluates the rules and needs, and I could be misunderstanding here, feel free to correct me at the end, wasn't able to pick up on that problem, and also doesn't have an API endpoint to make testing easier. And with a full configuration tool, expansion is limited and won't expand out defaults, since technically each job has an image. And so while linting tools do have their use, they are only a single piece of the puzzle, just like how we can't expect linters to catch logic errors. So if linters are lacking due to not testing end-to-end, why don't we instead try running an end-to-end pipeline before merging changes? Well, the good news is that GitLab lets us run a pipeline from a particular branch, such as the one that is introducing the CI config file changes. And it also lets us specify variables, for example, overriding those that would be predefined by GitLab. This is great because it lets us run a pipeline identically to how one would be run by GitLab, such as a post-merge pipeline. However, there is one limitation, being that this pipeline depends on the changes for that particular branch. And therefore, we won't be able to catch our problem as our branch doesn't introduce the changes that are needed to reveal that bug. However, there is another way, and that is by creating a branch off of our CI config file with any changes that are needed, such as updating a file that we expect to run in the test directory. And this is great, as it would finally reveal our problem. However, as you may have noticed, this is an intensive and costly process. It's slow and manual, and may not scale with all of the combinations of changes that may be introduced with lots of different rules. And so for our third method, we have something in between, something that's not as static as linting and not as end-to-end as running entire pipelines. And so for that, we can use tools like GitLab CI Local and GitLab CI Local. Yes, you heard me right. The difference is in a dash. GitLab-CI-Local is a TypeScript tool made by Massion Nilsson in January of 2020. And GitLab CI-Local is a Python tool made by Adrian DC in January 2020. It's honestly bizarre just how similar these tools are, both in what they do and when they were made. But anyways, these tools let us run the individual jobs for our GitLab pipelines locally using containers, with the core benefits being that they let us remove that dependency on GitLab, because we might not want to spin up an entire pipeline just to run a single job. This is helpful as it quickens the feedback loop by allowing us to locally replicate environments that might otherwise be too different to simply run as a script. And that's not to say that these tools don't have downsides. Being simulators, they're not always going to match the real thing. And if we're solely testing our changes, they don't give us any static information in advance and require us to wait for jobs to finish running. And so in our examples above, both of these tools also won't help us uncover our problem, even though they might have other benefits. And so with the fourth method, let's explore a different kind of testing. In this front, I wasn't able to find any kind of static analysis testing tools for CI config files, and thus, to solve this problem, I took the initiative to make a tool myself. CI test. CI test acts as the missing piece of the linting end-to-end integration testing puzzle by functioning as a framework for static analysis testing. Think of it as a toolbox to add to your shed of equipment. By analyzing the CI config file and how it's changed, we can gain a better understanding of what the pipeline is meant to look like. As an example, it can produce snapshots of the pipeline by collating relevant information, such as pairing together lists of changes and jobs. Thus, in our example, when that change was made, we would get this diff. This immediately lets us know that an additional rule set was created that is different from the expected rule set from all other jobs. And so really, what we should have seen is this instead, where all the jobs are defined under the same changes. Of course, like everything else, it has its drawbacks and can't be solely dependent on, since it doesn't run in integration like some of the other methods. But it is something simple that will allow us to quickly iterate on rules with confidence, which was something that we couldn't do before. That being said, don't take that as me going on the record to say that this will be the holy grail to all of your CI problems. There is plenty of room for improvement, and it's been written in a way to be highly extensible. So if you want to help contribute to this, or any other developer tooling, I'm more than happy to help. Reach out, make a pull request on GitHub, or come to the sprints. The last method I'll cover is using tools to dynamically generate pipelines using programming languages like Python. GitLab CI Python library is the only up-to-date library that I could find to do this. Although if you are interested, there are some TypeScript libraries which I had dismissed due to needing more attention. But anyways, GitLab-CI-Python-library, or GCIP for short, is a library from Thomas Steinbach and Daniel von Essen that allows you to replace your CI config file with Python. So why would you want this? Well, if we quote the library, we can utilize all the features of Python, such as code reuse, variables, control flows, and the like, programming paradigms, libraries, testing, packaging, and anything else you can imagine. It's Python after all. So what would it look like to replace our YAML with Python? Well, we first create a .gitlab-ci.py file. We then import the library, create a pipeline, specify the default image, then we create a job, give it a name, add the script, and its rules. We then do the same for all of the other jobs, add in our needs, before finally adding all jobs as the children of the pipeline, and then writing that pipeline out to YAML. And sure enough, we have this pipeline execute within the repo with all of our expected downstream jobs. However, has this caused our initial problem to go away? Well, it doesn't give us any protections from the pipeline failing to run, because again, there were no reasons for it to run correctly, since there was no .pu changes. And so unfortunately, it seems like generated pipelines won't directly solve our problem. That being said, they can help. Like the authors mentioned earlier, this programmatic approach does let you import your pipeline and perform tests on it, allowing us to do something similar to what we've done with CI test. However, there is one other thing to consider. Since our pipeline is now in Python, They do let us easily create a change set using a list. That we can apply everywhere and thus alleviate any rule mismatches, as now all rules will be referencing the same thing. This may have those of you knowledgeable in YAML thinking, doesn't YAML also let you create a list that can be referenced? And you'd be correct. We can create a key with an anchor and reference them with aliases to do the same thing and solve our problem. But if we wanted to do something like extend this change set, it wouldn't be as easy, as YAML doesn't allow merging of lists. Well, that's not entirely correct. GitLab does allow you to merge lists. However, this doesn't work for all cases, as it won't result in valid YAML. So, are generated pipelines a good idea? I think the authors have a really good view on this, which I'll do my best to summarize. The cons are that it could allow for writing complex pipelines that nobody else understands, when they should be basic things that build and test your code and shouldn't be in code too. But if you're not fond of YAML, your CI files are growing to over thousands of lines long, or they're littered with complex rule sets, then maybe writing them in code is cleaner. Importantly, it's a choice that's up to you, your team, and the situation at hand. So to close out, if we look back at the techniques and ask, what is the best approach? Well, it really depends on what your CI looks like. If your CI config file has become thousands of lines long, then generating it dynamically or writing tests may help relieve that burden. But at the end of the day, all of these methods are only tools to assist us in our problems. And if the underlying problem is the thousands of lines of CI configuration, it might help to start there instead. Because as complexity increases, so too do time-consuming problems that require testing to prevent. Choosing one tool over another will still be adding another component to something that is likely already complex that you'll just have to later deal with. And so if your pipeline is as simple as this, it may very well be reasonable to need nothing at all. Thus, my view from all of this is that simplicity is key. Question everything that is there and utilize the least you can to get the job done. You can find all related repos, tools, references, sources, and me if you want to get in touch or give feedback. I'm more than happy to hear it at citest.nohumanerrors.com. And if you're still wondering who tests the tests, I'll be around for questions. Thank you to my friends and family for supporting me, the open source contributors, and finally to you for listening. I'll leave this up now so you can actually take your pictures. Thank you very much.
I think we have time for one question. If anybody has one, raise your hand and we'll get a microphone to you.
I'll also stick around outside afterwards.
Does that pipeline generation package handle the more complex things you might have to do in a pipeline, like authenticate with AWS or authenticate to pull something in from a different repo from the one you're in?
While the pipeline itself is running?
Yeah. I have pipelines like that.
Yes and no. So when you're writing your YAML in Python, you can essentially import the Bodo library if you want to integrate with AWS, and then use that to authenticate with AWS while you're generating that pipeline. And then if you want to have the jobs themselves while running be authenticated, then that's something that you would have to have within your script. Does that answer your question?
Yeah,
Awesome, yeah, yeah.
I have pipelines that, you know, they pull in files from another repo, so I need to authenticate with GitHub.
Yes.
To allow that, you know, in the poetry file.
Yes.
In the TOML file, it references another repo. And then the deploy is deploying, you know, in Kubernetes at AWS.
Yeah.
So I need to be authenticated to do that.
Yeah.
And that's what I've found to be the more difficult part of writing the pipelines.
Yeah, I believe that would have to go in, like, within your scripts. But if I'm misunderstanding, then the pipeline generation, the tooling itself is actually quite extensive. And so it might also be able to do that. Like, I've only covered a very basic example, so definitely take a look, and it's open source. So if you find something that's missing, I'm sure the authors would love it.
All right, thank you everybody. Let's thank Evan one more time.
Thank you. Thank you so much.